Hello everyone, welcome to the fourth video of the Python baseline tutorial series. If you haven't watched the previous videos, please do so, especially if you are beginning your programming journey or you're a beginner in Python. As usual, this is the GitHub link for the tutorials, and here's the link for the exercises within this repository. So let's not go through many details about what functions are. This is the first video that concerns functions, so we're gonna do very simple things. There's gonna be a follow-up video in the second part that we're gonna do a bit more advanced things. But now for the very basics of functions, what we need to know is that a function is some part of the code that's somehow consolidated. So some part of a code is called, and we write this part of the code, and this part of the code either receives some arguments or some inputs and produces some outputs. So let's have a look in practice and see how these things work. So let's create a function that has no input and has no output. So in Python, when we type def, we define the function and we write the name of function that can be whatever we want. It is advised to write and to use a name for a function that tells something about what it does. So here this function simply does some kind of a greeting, so we can print like, I don't know, hi. This is a simple greeting. Okay, so whenever we run this part of the code, it does something trivial, so it just prints, but it might be necessary to do some more sophisticated stuff. Anyway, let's run this. You see that nothing happens. Even in the variable inspector, we do not see anything. So we have now somehow registered somewhere in memory that there is this function that runs whatever is within here. And to run this function, let's use a new cell. We just type this expression. So whenever we run this line of code, whatever happens to be within this function, so within this indentation level, you can see, as in the previous video with for, while, and if, indentation is what matters in Python. So within this indentation level runs. So here, if we run that, it runs whatever exists within here. So if we just type another line just to make it a bit less trivial. So let's use hi here, and let's type the second message below. So now we just run again this part of the code, we execute that, and now if we execute that, you see that it is typing that one. So now let me show you something. If we do something like that, so now we've added a third message to print. If we do not run it again, you see that there's no check mark here. So if we just run it again, since we have not run the new version of the function, it's remembering whatever existed before. So now we need to run it again. So now we have registered this version of the function. So now it is updated, and if we run it again, yep, it's gonna run like that. So this is a very simple, kind of silly function that you would, for example, use to print something if you're writing a game or something, and you might need to change it, or you might need to call it several times at several points within the code, and instead of typing the whole thing, you can just type that. You remember from the name, if you have named your functions correctly, more or less what they do, so it's more convenient conceptually to use functions in your code, more clear. Another type of function is a function that receives some input but does not produce any output. So for example, for this example here, we can just take this function as it is, define a new function, not as a simple greeting, but a simple greeting with name, and let's put an X here. So what this X does is it allows us to give something here. So when we call the function, it allows us to give something, and whatever we give here, it's getting there, and we can now use X in our code. So here, for example, we can say hi. Let's use X here, and let's put the exclamation mark here at the end. So now if we give a name here, it will say hi, whatever name we give, exclamation. So if we give, for example, Alice, hi Alice, Bob, hi Bob, whatever. So now let's run this function. Let's actually register the function, and now go and run it. So get this simple greeting with name. Again, we can name it the function whatever we want. We can name it whatever we want. And let's give like Alice or whatever. So now you see that it says hi Alice. We can also say Bob. It says hi Bob, or I don't know, Clara or whatever. So you see that here we can give an input and somehow modify the behavior of the function, like so. Okay, now let's have a look at functions that receive no inputs but produce some output. So those functions actually didn't produce some output, they printed something, but they didn't return any value, they didn't return any variable. So now let's use the example of the Fibonacci sequence. So let's write it down very quickly. You can Google what Fibonacci actually is, what Fibonacci numbers are. So we start with an empty list, and this list will be getting populated while the program is running. And let's say that we want the first one, the Fibonacci that are smaller than 100. So we will return a list with the Fibonacci numbers up to 100. So let's, for example, initially start with an A and a B that is 0 and 1 respectively. So A is 0 and B is 1 initially. A will be the number that will be holding the Fibonacci sequence. So let's check if A is smaller than 100. This is the numbers that we want. And let's just append A here in the list that we are creating to return. And after that, let's update A and B as follows. So A will be what B was, and B will be what A plus B will be. So here we are creating the Fibonacci sequence. It doesn't really matter what the sequence is. What we care about is that we are creating a list that we are giving back to the program. So whenever we call this Fibonacci function, we're getting something back. This is the important thing. So let's register the function. Now let's run it. We need the parentheses because it's a function, even if we do not give anything as an argument. And let's run it and see what it produces. So it has produced a list. You see that it has produced 0 and 1, 0 plus 1 equals 1, 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, and so on. So this is the Fibonacci sequence. But you see that it has printed, it has outputted this and printed it since we didn't catch it with a variable. So we could say that y equals that. So now if we run it, you see that no output is produced. However, if we go to the variable inspector, you see that we have created a y variable that is a list with 12 items, the items that we have gotten, that the Fibonacci function has returned to us here. So whatever a function returns goes to this position. So if you say something equals whatever a function is doing, or however you define a function, the return component of the function goes on the left side of the equal sign. This is the normal way to do it. So you can now, for example, print y if you want. Great, so this is y, we get y, and y is a variable that we can use later on in our program if we want. As you have imagined, we can also do the same thing. So we can create a function that has input and output, we can use the Fibonacci example again and say that, okay, we do not want necessarily up to 100, so we can have Fibonacci up to number, and let's say that we give like n here, for example, and n would be like given by the user or by the caller of the function. So here, if a is smaller than n could be 100 or it could be whatever the user wants. So if we run it now, you see that it receives an input, but it also produces an output. So let's run it again, and let's say that y this time will be like the Fibonacci up to number. Okay, common practice would be to just run it for the previous range and see if we get consistent results, so that the change we have made, okay, it indeed produces the same output as earlier. But now we can go up to 1000, for example. You see that it didn't produce too many numbers after that, so up to 10,000, still not that very many numbers after that. So yeah, you can experiment and see, for example, as you increase the powers of 10, how many new numbers you get. It will possibly converge somewhere. That's somehow a good exercise. I will add it to the exercises. Okay, great. So we can also have functions that receive multiple inputs and also produce multiple outputs, or whatever combination, single input, multiple outputs, multiple inputs, single outputs, or multiple inputs, no outputs, whatever you want. So let's, for example, create a function that receives two numbers and outputs the basic arithmetic operation. So for example, let's say this function would be like basic arithmetic ops of two numbers, so x and y, and let's say that this function, what it does, it produces an a, which is like, or let's call them explicitly, so sum is like a, not use this word, this is summation, for example, is y, x plus y. Okay, so subtraction is x minus y, multiplication is x times y, let's use spaces here as well, and division is x divided by y. And now let's assume that we want to return all of those components, all of those computations. So the return part of the code will have all the aforementioned component summation, subtraction, multiplication, and division. Okay, so if we run that, we register the function, let's create a new cell and run it. So actually, let's run it down here because it has the no, let's run it in a previous cell like before. Okay, so we can now get the summation, the subtraction, the multiplication, and the division if we run the function. Let me copy paste that to make sure that nothing goes wrong. Okay, and let's put, for example, in like, I don't know, 5 and 6, and let's run it. Now if we run it, you see that we have whatever exists as a first item after return, we get it to this variable. Whatever exists here, we get it to that variable. Those names could be whatever they want. They are not related. Something that conceptually makes it easier for us to understand what we're writing. Division comes here. And now if we open the variable inspector, you see that all those variables are here. So we can also print them, but we can have a look here. So this is the division, this is the multiplication, subtraction, and summation. Okay, so what we can do now is we can get all those outputs of this function into a single component, a single tuple. So let me copy paste the entire thing here, and we do not need a new cell, and just type y equals that. So now y will grab the entire thing, all those outputs. So now y is a tuple with 4 items, and you see that it has taken summation, division, etc. So this is a way to get everything in one go. Sometimes we need all of those separately, so there is a special case where we can ignore some outputs. For instance, we might not need something, and so we might not need subtraction, for example. So if we place an underscore here, and let's say this is, I don't know, like let's say A1, just to change the symbols a bit, A3. So now we're ignoring that. So now we're getting nothing. We're getting A1, A2, and 3, and A3, but we have nothing here to get, so it's just ignoring it. And we can ignore more outputs. So if we if we are just interested in summation and multiplication, we just do it like that, and it ignores whatever output exists here and here. Okay, this is the first part of the huge topic of functions. So you can have a look at the GitHub page, and also have a look at the exercises. So until next time, bye for now.